Greetings and welcome. We are continuing our look at parallel and perpendicular lines, and we're going to talk today about perpendicular lines, which isn't that big of a change. But then we're also going to find the distance from a point to a line, and is all I've got to say about that. Let's find out how this goes. So we'll keep rolling back to these steps in a moment. Let's jump in and look at example 4. It says, write the equation of a line passing through the point 2, 3 that is perpendicular to the line 2x plus y equals 2. So step 1, I'm going to find the slope of the line given to me, which in order to do that, it's usually convenient to write it in slope or point, slope intercept or slope, slope intercept point slope, blah, blah. I can't talk. Slope intercept form or point slope form. There we go. So now that it's solved for y, what, my friends, is the slope? M1 is -2. Now notice our line is perpendicular. So our slope, yeah, thoughts? Change it up a little both ways, right? Let's flip it and change the sign. Do that opposite reciprocal. So the opposite of negative, it's positive, and the reciprocal of 2, or refliprical, as I like to say, is 1/2. So here's our slope, and the rest of this problem will now behave near identically to the other problems we've done. So I also have a point here, x1, y1, and so I'm going to plug this point, that slope, into probably y equals mx plus b, because that's what you guys seem to be fans of for some reason. And so I'll have 3 equals 1/2 of 2 plus b. And, oh, I swapped colors too quick. Let's simplify that. 3 equals half of 2 is 1, and then subtract the 1 from both sides. Man, good old solving. Let's see, I'll switch it to red here. So I got b equals 2. And so the equation of our line is going to be y equals 1/2 x plus 2. Tell you what, let's do a Desmos graph, which I know that's why Ryan was pulling out his phone as well. Desmos.com/calculator. And let me switch over to projector mode. And let's see. All right, here we go. So let's write one of those equations, which, what's cool is, Desmos, I can even plug this equation in standard form. 2x plus y equals 2, 2x plus y equals 2. All right, so there's the first line they gave us. What was the point they wanted it to pass through? 2, 3? 2, 3. So there's 2, 3. And let's see if it makes sense that our line is going to be perpendicular to their line. Our line, we got y equals 1/2 x plus 2. So y equals 1/2. I have to hit over to get out of that denominator. And oh, it's perpendicular looking. But now when I hit plus 2, bam! Direct hit. Look at that. Thing of beauty. Wow. That's awesome. Wow. So yeah, so it seems to make the sense, I believe. Let's see, where am I at? So there's example 4. We'll do some more of those in a moment. But let's talk about the real beast today. Finding the distance from a point to a line. Let's see. All right, finding the distance from a point to a line. I really, yeah. Google Docs equation editor. I'm going to call them out. I'm a huge fan of Google, which I know Ryan is sending some reviews about Google Docs right now. Yeah, I got to be honest. Google, your equation editor needs some work, friend. Yeah, that was probably the meanest thing I've ever said in my life. I'm calling them out. Even though I love Google, even though I've got Google Sheets like crazy, it's one of my favorite things in the world. But wow, Google, look at this. Look at that. Your vinculum is skinny and not in the right spot. Wow. Well, so guys, check this out. If I want to find the distance from a point to a line, tell me, first of all, how would I measure that distance? If I wanted to figure out from this point to that line, would I measure it like this and like, oh, it's 2 units away? Or shouldn't I measure it perpendicularly? Yeah. Yeah, I should. Right, Ryan? What's your friend saying? Did they say perpendicular? Oh, man. Did they use the perpendicular emoji? They did, didn't they? I think they did. So yeah, so I've got to measure the distance to the line perpendicular, but the problem is all I have is the equation of a line, and I have a point. So I'm going to, first of all, need to find the equation of the line that is perpendicular. All right, so I'm gonna find the equation of the line that's perpendicular. All right, it'll look something like this. And we're going to do it not graphically, but by an equation. So that'll be the first thing I do. Then I'm going to need to figure out where's the point where this perpendicular line crosses the original. So that's going to be solving a system of equations using substitution or elimination. And then once I've located that point, I'm then going to use distance formula to find the distance between those 2 points. So this problem has a lot going on, all right? So that's where we're starting here. It says find the equation of the perpendicular line through the point, which notice was like pretty much the entire previous problem, right, Ryan's friend? They're agreeing with me. You can be friends with your mom, though. You can be. It's true. My son Rook said I'm his dad and his friend. It's true. I doubt that'll always be the case, but that's okay. Rook, I'll always be friendly to you, Rook. R-O-O-K, Rook. Like the chess piece or the bird from Europe that's like a crow. Yeah. No, neither. That's just his legal name now. Haha, take that, wife. Who won that name game? So anyways, let's find the line perpendicular. So the slope of the line they gave us is -1, right? And so our slope is going to be what? Here's step 1, finding the equation of the line perpendicular. What's our slope going to be? Actually, not whatever I want it to be. Yeah. Yeah, the reciprocal that's opposite of 1, is -1 is +1. So our slope is 1. And I'm going to plug into y equals mx plus b. I'll plug in 0 for y, 1 for m, and 1 for x, and we'll solve for b. So 0 equals 1 plus b. And we'll subtract 1 from both sides. I get bravo equals -1. So the equation of our line, I'll make it our equation purple, is y equals 1x, or just x, minus 1. So that's the equation of our line. And we can even graph that if we wanted. Let's graph it, because I've got it. And I think I gave you guys this graph as well. So starting at -1 for the intercept, the y-int, and then moving up 1 and over 1 and up 1, over 1, up 1, over 1, up 1, over 1, like so. And now I can draw a line here. Like so, and we'll even make it purple so it matches the thing that we're doing. So there's the equation of our line. Now the next thing I've got to do is find out where is that intersection. All right, so where is the intersection? Now I realize in our example here, especially since I have the graph and it lands on a lattice point, you could just read that intersection probably pretty easily, but I'm going to do this algebraically because we're not always going to have a graph and it's not always going to land at a pretty point. So it says find the intersection of the two lines, and you can use substitution or elimination method. and you can go like search Wadi Math for like substitution, and you'll find it, I'm sure, if you need some help on this. But I'll walk us through. So we've got two equations, right? We've got y. Here, I'll write it down here. Y equals negative x plus 3. And our equation is y equals x minus 1. And what I'm going to try to do is solve for the one point that makes both of these equations true at the same time. Right? Think about it. Like, this blue line has infinitely many points that make it true. This purple line has infinitely many points that make it true. But there's only one, like, holy grail of all points that makes both of them true simultaneously. And one of the ways we could figure that out was using substitution, which I think is usually the friendliest way for people to solve it. And step one of substitution is solve one of the equations for one of its variables, which, notice, this is already solved for y. That's already solved for y. So that step was easy. And then the next step is to substitute. All right, if this is equal to y, I can now plug it into the other equation's y. Like this. I don't know. I think you might be right. So notice the benefit of this substitution move is that now I have a single equation with a single type of variable. All right, and we are experts at solving single equations with single types of variables. We'd solve for x. I'd add x to both sides, and I'd have 2x minus 1 equals 3. And then, yeah, it looks like, right, 2x equals 4, div 2. Let's see, did they also get the same answer, Ryan? Nice. I get x equals 2. Now, I'm looking for a point, and this is only the x coordinate of that point. That's only half of my answer. But notice, if x equals 2, I could now plug this 2 in for x in either of the original equations and solve for its corresponding y value. All right, so I'm going to have y equals, and instead of x, I'll have 2 minus 1, or y equals 1. And that means the point of intersection is 2, 1. Let's graph that and see what that looks like. Over 2, up 1, direct hit. That's right, kaplow, sound effects. Thank you. So this is going to be my second point. I'll call that x2, y2. My first point I think I called x1, y1. And now what do you guys think I could do for step 3? Use the distance formula. I'm trying to find the distance from this point to the line, and right. I like it. So using these 2 points, find the distance. Blah 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 blah. Distance formula. All right. Let's see. I'm gonna earn this slow clap. I hope. I so hope I do. So distance is gonna equal x2 minus x1 all squared plus y2 minus y1 all squared. And for us, our distance is going to equal, let's see, what were our points? Man, here we go, scrolling. 2, 1 and 1, 0. I'll write those down. All right. So I'm going to have 2 minus 1 all squared plus 1 minus 0 all squared when I plug it in. And now it's just a matter of order of operations. 1 squared plus 1 squared. Ooh, no way. 1 plus 1. It's the square root of 2, friends. It is about 1.414 infinitely long, non-repeating decimal here. Yeah. So the square root of 2 is the distance from our point to the line Yeah, you guys are still right in there. Which I want to point out was the diagonal of one of our boxes here. Right, this was a 1x1 box, and the diagonal of a box is not 1, which I assume you guys knew that. It's the square root of 2. Or we might even say later, it's the square root of 2 times longer than the sides of a square. All right, so that's the general idea. There's only 2 types of examples that we had today, and the second type had the entire first type built within it as its first step. And then this is probably the hard part, is remembering these pieces. So we're going to just do some class questing so we can become practiced and familiar with this. So thank you for watching, mis amigos.